find out for the top beam as well. So let's get started. Now I'm here in the drawing, and we have a cross section and the longitudinal section for the top beam here, and you can see both of these beams are pretty same. Here in TB1 we have same supports over here, the 1, 2, 3, 4 and 5 supports, but we have some change in the reinforcement only, and all of the reinforcement are the same. You can see at the bottom we have the top bar, extra bar, we have top extra bars over here, but we have one another bar that is extra bar, that the mid support, that is the difference over here. So with the same method you can find out over here. So I'm not going to find out TB1, TB2, TB3. I go and I'll find out only TB4 over here. Rest with the same method you can find out TB5 and TB6 as well, and TB7. So in TB4, TB mean top beam. TB4 we have the longitudinal section over here in the cross section over here. And in the longitudinal section we can see we have at one end we have the column, and at another end we have beam. You can see over here. Let's go into the plan for the top beam. This is top beam plan, and this is our TB. At one end side we have the column, and another side we have beam, and same goes for this one as well. One side column, one side beam, and this is also same as TB4. The length is same, so we will consider this as well as TB4. Now let's move again into the TB4, and let's check the longitudinal section. In twin dimension over here is 3825 millimeter. So in twin dimension means center to center, from one spot to another spot, it is 3825, and this is 225, this is 225. So what is the external dimension? 3825 plus 225. So external is 50 millimeter. Let's check it, let's verify it. Go with DL command, start right from this position, and external dimension should be 40-50 millimeter. You can see over here, so it is 40-50 millimeter, and this also right from this position up to here it will be 40-50, and this also. So all of these are TB4. Now let's go again into the longitudinal section and check the reinforcement details over here. Now in this beam we have a straightforward steel. At the top and the bottom we have only the main bars, no extra bar is over here. We are using 2 bars 12 mm, the main bars at the top and the bottom as well. And for stirrup we are using 6 mm 300 center to center. So this is what we need to find out over here. Top and the bottom we have same main bar, so I'll simply go here in this Excel, serial number as 1, then I'll go with the TB4. And then what about the length? The external length is 40-50. We have checked it. Breadth 225 and height 225. Particular placing of bars, so it is main bars, top and bottom. Next to it, spacing between bars, there is no need to add the spacing because these are main bars. So for the shape, I'll simply go here and I'll create a shape. Click on this drop down, draw border option, and I'll create shape over here. Next to it we need to go for the bend deductions, and bend deduction we have 290 degree bends. So it is equal to 2 into 2 into dia bar. Hit enter. Next to it bend of the revolvement length. This one I'm talking about, and we are taking this as 12 into D. What 12 into D? So let's put it over here, 12 into D equal to 12 into dia bar. Sorry, we have put it under this one, equal to 12 into dia bar is over here. Next there is no need to add the overlap over here. Let's put the dia over here. 12 mm is the dia. Concrete cover in the beam we are using as 25 mm. Number of bars, we have a number of bars 4. Top and the bottom I am talking about. Multiply by number of members as 1, and then total numbers will be equal to number of bars multiplied by number of members. Hit enter. Next to it, what we need to do is we need to find out the total length, and in order to find out total length, first of all what we need to do is we need to find out cut length. So bend is over here, and this is also equal to this one. Sorry, it is equal to this one. Next, what about this horizontal? So from the total external length, let me just show you. From the total outward dimension, we need to deduct the concrete cover from the both ends. So it is equal to Outward dimension is this one minus concrete cover from both ends. Hit enter. Next to it, what we need to do is we need to find out the total length, and in order to find out total length we will go here, this one plus we have this one, we have this one, and then we need to do the bend direction of 90 degree, multiply it with the total numbers, divide it on 1000 in order to convert it into meters. So we have the total length over here for both of these bars at the top and the bottom as well. So this is how we can find out the total length over here. Next to it, definitely we need to find out the stirrups as well. So let me copy all of this stuff from here, no problem. But here in the length we will take here into dimension for the stirrup, right from this position up here. So center to center is 3825 minus 225 from both ends, so it is 3600. Put it over here. Next it is okay for us. I'll write here stirrups spacing 300 center to center. Let me check it again. 300 center to center, it is okay. Next we need to create a shape for this, so I'll click on this drop down and I'll go with draw border option. Sorry, not draw. I'll go here and draw border. I'll draw the border over here. Now next to it, what we need to do is we need to go for the bend directions, and we know for stirrups we have 390 degree bend, so equal to 3 into 2 into diap bar. Hit enter, and we have 135 degree hooks, 2 into 3 into diap bar. Done from here. Next to it, we have hook length over here, and hook length we are using in the stirrups is 14 into D. You can check in the general notes as well. Equal to 2 into 14 into diap bar, 2 because we have 2 hooks. Next, there is no any overlap over here. Diap bar we are using 6 mm, concrete cover 25, and number of bars, so it is equal to into in span, that is 3600 divided by spacing is over here plus 1. Hit enter. We need total of 13 stirrups over here, multiply by number of members as 1, and then total numbers will be equal to number of bars multiplied by number of members. Hit enter. Now in order to find out total length, first of all we need to find out the cut length. So all we need to do is we need to go here. This is equal to 225 minus concrete cover from both ends, and this is equal to this one. Now it is equal to this one minus concrete cover from both ends. Now next to it we need to find out the total length, and in order to find out total length, it is equal to we need to add all of this one plus this one plus this one plus this one minus, sorry, before that we need to add the hook length as well, minus bend direction 90 degree 135 degree, and then multiply it with the total numbers, divide it on 1000 in order to convert it into meter. So we have find out the total length over here as well for stirrups. So this is what we need to find out over here in the TB4, and let me just go here, and it is very important to check one of the thing over here. Remember one thing, we are finding TB4, and how many TB4 we have over here, let me show you. In the plan we can see we have TB4 as 1, 2 and 3. We have 3 TB4 over here. So in number of members I'll put instead of 1 as 3, so we can find out all of this stuff over here, 3 over here as well. So it is important to check how many beams we have, actually the same beams, and we are done up to this position. We have find out the main bars in the TB4, we have find out the stirrups as well, and this is what we need to find out over here. Now in next tutorial we will find out BBS for the stair as well.